Hello everyone, welcome back to my YouTube channel. Myself, I am Mansa. I'm from the Department of Electronics and Communication. I'm currently pursuing in 4th SEM ECE. Today my topic is PAM and FDM. Before going to that, let us see multiplexing. This multiplexing is refers to the combination of information streams from multiple sources for transmission over a shared medium. This multiplexer is a mechanism that implements the concepts. Next, demultiplexing is refers to the separation of a combination back into separate information streams. Next is demultiplexer. It refers to a mechanism that implements the concepts. Figure illustrates the concepts. Each sender communicates with a single receiver. All pairs shares a single transmission medium. Multiplexer combines information from the sender for transmission in such a way that the demultiplexer or demultiplexer can separate the information for receivers. This is the concept of a multiplexing. So here we can see the multiplexer. It can sender 1, sender 2, so up to sender n. So if we come to demultiplexer, it is a receiver where a multiplexer is a sender, where demultiplexer it receives a receiver, that is receiver 1, 2 to up to receiver n. So this is a concept of a demultiplexing in which independent paths sender and receiver shares a transmission medium. So next is what is the need of multiplexing? So transmitting two or more signals simultaneously can be accomplished by setting up one transmitter receiver pair for each channel. But this is an expensive approach. So a single cable or radio link can handle multiple signals simultaneously using a technique known as multiplexing. So multiplexing permits hundreds or even thousands of signals to be combined and transmitted over a single medium. So cost saving can be gained by using a single channel to send multiple information signal. So this is a multiplexer MUX or MPX combines all inputs into a single signal where a demultiplexer processes input signal by sorting it out into the original individual signal. So we can see the multiple input signals where multiplexer it gives a multiple input signal where demultiplexer it original input signals. So this here we can see this single communication channel is a wire or radio where this multiplexer it gives multiple input signal where a demultiplexer original input signal. There is a multiplexing in networks. So this main purpose is if and show it main purpose is to send and sharing the medium. So frequency division multiplex. So separation of a spectrum into smaller frequency bands. Channel gets band of the spectrum for the old time. So let's see advantages. No dynamic coordination needed. Works also for analog signals. So what is the disadvantage? Is waste of bandwidth is if traffic distributed unevenly. Is inflexible. So guard spaces. So let us come to the frequency division multiplexing, that is FDM. Each signal is allocated a different frequency band, usually used with analog signals. A modulation equipment is needed to move each signal to the required frequency band channel. So multiple carriers are used, each is called subcarrier. This multiplexing equipment is needed to combine the modulated signals. So this is we can see the process of a FDM process where modulator is carrier F1, this modulator carrier F2, is a modulator carrier F3. So in carrier F1, the modulating the sine wave is of simple, and if we come to carrier F2, the sine waves increases a little bit. So if we come to carrier F3, the monitor or the sine wave, it is a more in carrier F3. So this is a FDM demultiplexing for example. So this is a signal we can see. So this is a demodulator carrier F1 and demodulator carrier F2, demodulator carrier F3. So this is a so for example of a FDM demultiplexing. So this is we can see communication channel where LPF, that is nothing but low pass anti-analyzing filters. So first if we use the message inputs, later that it goes to low pass anti-analyzing filters. So upon that it comes to communicating channel. First this is a commutator, and next it goes to decommutator. In decommutator we can see LF, LPF. So this is a message outputs where commutator gives a message inputs, where decommutator it it takes message outputs. So next is PAM, that is pulse amplitude modulation. Is a form of signal modulation where the message information is encoded in the amplitude of a series of signal pulses. So it is an analog pulse modulation scheme in which the amplitudes of a train of carrier pulses are varied according to the sample value of the message signal. So demodulation is performed by detecting the amplitude level of the carrier at every symbol period. So this is we can see this a time domain, this is a frequency domain. So here we can see the how time domain is varied and frequency domain is varied. This is a signal shown of PM signal. So in this noise accept, this type of signal is easily by noise. This is a type of flat top sampling signal. So it is a flat top sampling signal. So sampling methods in PAM. So this ideal and natural sampling signals can eliminate noise. Ideal sampling signals difficult to generate. So this is a sampling method in which is used in PAM. So thank you for watching my video. Please like, share.